Welcome students to Flip the Classroom Lecture 5-2. A couple things before we get started today. I'd like to apologize, but eventually I will try to incorporate the figures that are mentioned in the lecture in actual slides. However, I'm just currently running out of time. Plus, to be quite honest with you, I really don't know how to do it yet. So those things will be coming at a later time. In the meantime, I try to have your either online chemistry textbook set up so that you can stop the video and refer to those diagrams. They will definitely help you be able to comprehend a little bit about what's going to take place during this lecture. I'd also like to recommend that you probably get our little diagram friend right here that you colored. Might actually be able to reference back to it as well. How was that for fancy technology? But in the meantime, we are going to go straight through this lecture today. I'm not going to stop it. It's actually 5-2, the electron configuration and the periodic table. Under A, group 18 elements have few chemical reactions. Number 1, helium has a full 1s or full first energy level, and the other noble gases contain the stable octets, O-C-T-E-T-S, of electrons, S2P6. B, periods and blocks of the periodic table. Number 1, elements are arranged vertically in groups with similar chemical properties. Number 2, there are in horizontal rows or periods. The total periods is 7. Take a look at table 5-1 of your online textbook. Under A, length of the period is determined by the number of electrons that can occupy the sub-levels being filled in that period. B, period 1 is equal to 1s. Period 2 is equal to 2s and 2p's. In other words, we have 8 electrons and 8 elements. Period 3 is equal to 3s and 3p. We have 8 electrons and therefore 8 elements. Letter E, period 4 is equal to 4s, 3d, and 4p. We have 18 electrons. The same pattern is found in period 5. Under F, period 6 is equal to 6s, 5d, 4f, and 6p, with a total of 32 elements. The same pattern is found in period 7. Under G, electron configurations of elements in the periodic table are divided into 4 blocks, the S, P, D, and F blocks. Take a look at figure 5-5 out of your online textbook. Number 3, the S block elements, groups 1 and 2. Under A, the S block are chemically reactive metals, but group 1 is more reactive than group 2. Under B, group 1 elements need to lose a single electron and are extremely reactive. Under C, the ending configuration are NS1 and NS2 for groups 1 and 2. Under D, group 1, number 1, lithium through francium are the alkali metals, spelled A-L-K-A-L-I. Number 2, they have a shiny appearance and soft and can be cut by a knife. Number 3, they are not found in nature as free elements because they combine vigorously with most non-metals. Number 4, they react with water to produce hydrogen and aqueous solution alkalis, so they are stored in kerosene. The melting point decreases as you go down the group. Under E, Group 2, number 1, beryllium through radon are the alkaline earth metals. Number 2, these metals are harder, denser, and stronger than Group 1. They have higher melting points and are less reactive than Group 1. Number 3, these elements are too reactive to be found in nature as free elements. Number 4, we need to talk briefly about hydrogen and helium. Under A, hydrogen ends in 1s1, but does not share the same properties as other group 1 elements. It is unique, unique, sometimes is considered as a group by itself. Under B, helium ends in a 1s2 with two 1s filled electrons, but possesses special chemical stability and is unreactive like group 18. The other group 2 elements do not have a filled energy level and must fill the empty available p sublevel. Now we're going to go and try and have you do sample problem 5-1 out of your online textbook. And tomorrow when we get to class, we will actually go over that sample and we'll do a few more problems, something similar to it. But I really want you to take a look at that sample problem before you come to class and try it out on your own. Number 5, the D block elements are groups 3 through 12. Under A, group 3 electron configuration is NS2.
Please excuse this interruption. Would Stacy Matthews, Kennedy Core, and Caitlin Steerwald please report to Mrs. Oliver's room? And would Brianna Ruffus please come to the office?
Time for one of those edits, maybe. I just might leave it in there so you can see how many times I really am interrupted. Anyway, under A, group 3 electron configurations are NS2 and then N-1 in parentheses. Under B, group 12 electron configuration is still NS2 with N-1 in parentheses. Under C, some deviations occur in between these so that they do not necessarily have identical outer electron configurations, but the sum of the outer s and d electrons are equal to the group number. Under D, D block elements are metals with typical metallic properties and are called the transition elements. Under E, they are good conductors of electricity and have high luster. They are less reactive than alkali metals and alkaline earth metals and do not easily form compounds and exist in nature as free elements. PD, PT, and AU, which stands for gold, are among the least reactive of all elements. Again, we will try to send you to do sample problem 5-2 and we will go over this in class. Under C, chemical commentary, the wild kingdom, number 1, the P block elements are groups 13 through 18. Under A, the outer configuration is NS2 NPX, where X range from 1 to 6. B, main group elements are the P block elements together with the S block elements. Under C, periods 4 and higher, total number of the highest level is equal to the group number minus 10. D, at the right hand of the P block, includes all the non-metals plus hydrogen and helium. Under E, along the transition line, are all 6 metalloids, metalloids, and they are B, Si, Ge, As, Sb, and Te. Under F, at the left hand and bottom of the P block are 8 P block metals. Take a look at figure 5-6 out of your online textbook. Under G, group 17, number 1, F through 8At are the halogens, Halogens. Number 2, these are most reactive nonmetals and vigorously react with most metals to form salt compounds. These need to gain one electron to have a complete octet like the noble gases. Number 3, fluorine and chlorine are gases. Bromine is a reddish liquid, and iodine is a dark purple solid. Under H, metalloids or semi-conducting elements fall on both sides of the transition line that separates metals from non-metals. They have intermediate electrical conductivity. Metals are good conductors, non-metals are non-conductors. P-block metals are harder and denser than S-block alkaline earth metals, but softer and less dense than the D-block metals. These minus Bi are sufficiently reactive and only found as compounds. As free metals, they are stable in air. Number 2, we want to work on the sample problem 5-3, and then again we will start with these in class and then work on a few more examples. And number 3 involves practice that we will do in class. Number 4, the F block elements are the lanthanides and actinides. Under A, wedged between group 3 and 4 in the 6th and 7th periods. B, the lanthanides are 4 F electrons involve filling 14 electrons from La to HF in the 6th period. Under C, actinides are 5 F electrons involving filling the 14 electrons from AC to, as the old periodic table had it, U and Q in the 7th period. The first 4 actinides are naturally found elements, but the last are laboratory elements, and since the time of the printing of our periodic table, most of them have already been developed. The next thing that I'd like to have you do is to do the sample problem 5-4 in your online textbook, and then again we will practice these and go over it in class. This concludes the very long, exciting lecture 5-2. We'll try to break up the remaining lectures a little bit less so it's not quite so painful. Anyway, I hope that you enjoyed it. Have a great evening or day or whenever you're viewing this from your good, insane chemistry teacher, Mr. Slay. Have a good day.